Hey everybody, this is Alex Merced from alexmercedcoder.com, and in this video we're going to go over maps, structs, and receiver methods. So we're going to cover a lot. Okay, so first let's cover a map. A map is just basically key value pairs in Go. Okay, all the keys though have to be of the same type, and all the values have to be the same type. So it doesn't necessarily work the same way that let's say a hash in Ruby or a dictionary in Python or an object in JavaScript, where you can kind of mix and match at least the values. Well, let's see here. Let's create a map. Okay, so let's see here, my map. Okay, my map equals, okay, equals a map. Okay, and then we have to specify the type of map. And that's going to be a map where the keys are strings. And we'll say that the values are integers. Okay, and then we can specify the map. So say first one is Alex's age. Okay, which will be 34. Then we will have Bob's age, which we'll say is 55. Okay, and let's see, what is it complaining about? Okay, needs a trailing comma. So, cool. Then we can just print my map. Okay, and then we're specifically going to print out the key, Alex age. Okay, let's see why it doesn't like that. Oh, that's right, because it's got to be double quotes. There we go. So let's run that. Let's make sure that works. And there you go. So see, I made a map. So I made a collection of key and values. And that works. I mean, that's fine if I need to do a collection of integers or a collection of booleans. Like if all the information is going to be of the same type, this works. But oftentimes when we create key value pairs, we are oftentimes having a lot of items of the same shape. And this is where a struct comes in, where we can specify a shape of our data. Okay, so we can be like struct. Oh, technically it's got to be type. So we're going to create a type called person. And a person is a type of struct. And then we define the struct. So we'll say every person has a name. Okay, which is a string. And every person has an age, which is a int. Okay. There we go. And there we go. So now what I can do is I can say, hey, my map, we have a string, but then instead of each item being an integer, I can say each item is a person. Okay. So basically the way it would work is instead there would be, well, that would make sense as that particular struct in that map. So we're going to say my array of people. So we'll create an array called persons, which is going to equal a array, or technically, well, it could be a slice of person type data. Okay, and the first one is going to be name, Alex, age 34. Then second one will be name Bob, age 55. Okay, so you see here, it's going to create an array out of the data that I pass in. So first we'll print out the actual array. So we'll print out persons. Okay, and let's see if that all works out the way we'd like it to. And there you go. See, hey, inside the persons array we have Alex 34 and Bob 55. And if I want to print out persons 1, which would be Bob, and I want to print out that name property, I should be able to just do that. Okay, the name of the person, but that should be name with an uppercase N, because that's how I spelled it. And see, just print out Bob's name. Okay, so struct allows me to create sort of a structure of data. Like, because technically, Go doesn't have classes. So Go doesn't really support traditional object-oriented programming. It doesn't support inheritance. It does kind of support composition. So I can create these structs, but let's say I wanted to have a function that persons have. Like I want person to be able to speak. Okay, I want to be able to say their name. Okay, so basically here's how you'd have to do that. So I have to create a function. Okay, and the function before its name takes an what's called the receiver argument. Okay, and I'll say the argument is p for person. Okay, so that's going to be our sort of our variable, and what p is a person. Okay, so we're just saying, hey, there's this receiver. This is a function that belongs to the person struct. So any data that is technically qualifies as a person struct can use this function. And we're going to call this say name. Or say my name. Okay, it'll take no arguments. It'll return nothing. All this is going to do is print hello. My name is space. We'll use some concatenation plus p dot name, because we know that p is the person who's invoking this function. Okay, and there we go. So now technically I can be like p persons 1, which is Bob, because 1's the second index, 0 would be Alex. I can go persons 1 dot say my name, there we go, and it should be able to say my name. Let's see here, it gives me a little red thing. Let's see why. And nothing. Oh, that's because I'm printing it. Yeah, let's get rid of the print here. That should clarify. There we go. Okay. And see, it says hello, my name is Bob. And I can do persons 0, which would be Alex, and be like dot say my name. Cool. And do that. Okay, so now they do have functions that are available to them that can use their properties as a struct, but they're not in this package that's called a class. As you'll see later on, I'll do a separate video on interfaces, because what happens, what if you have a function that you want it not just on person structs, but maybe you also have aliens, and you want the aliens to have a say my name function. What you'll be able to do is create like an interface, and the interface could just basically apply to anything that has a name property, which would include alien and person. Okay, actually let's just cover this now. So let's talk about interfaces while we're here, because what would happen is if you want to use the same function across multiple types, here's how you do it. Okay, so let's first create aliens. So let's create a new struct type alien struct. Okay, and struct also has name, string, age, int. The only difference is they also have a planet. That's what makes the aliens different, which is also a string. Okay. Cool. So now we have that. So now I want to create a interface that would include both of these. Now, the way interface works, it doesn't do it based on properties. It works based on methods. So they have to both implement the same function. Okay? So I could use say my name, and then we can go into then try a third function. So what I would need to do is then implement this say my name function again for alien. Okay, so then I'll do this again, except this time it's going to be A for alien. So the alien is the receiver of this version of say my name, and it's A. Okay. So now both of them have an implementation of this particular function. Let's clean that up. Okay. So now what I can do is I'll go over here and create a type called sentient, meaning all sentient beings, which is an interface. And this interface applies to any type that is able to implement the say my name function. Okay. Cool. So technically both of these are sentient beings because they can both implement the say my name function. So now I can create a new function. Function, in this case, we'll use S for sentient being. So I'm naming the type sentient as the receiver. Okay, and this will be called stats. Okay, and this will take no arguments. Okay, and what all it'll do is print itself. Print S. Okay. But see, now I've only written this function once, and now both of them will be able to use it. So let's just try that out. Let's create an alien. So first we'll create me. Alex will equal a Okay, so first we'll create, let me get back over here. Alex will equal a person. Okay, and then the person with the name of Alex Merced and age of 34. And then we're going to have Zim, who's going to equal an alien. Oh, okay, and these need to be walrus teeth. There we go. This needs to be an alien, and this alien's gonna have a name. It's gotta follow the struct. Alien of Alex. No. Alien's name is Zim. Their age is 5,000 years old. And their planet. I forget that I do planet uppercase. I did do it at planet uppercase. So again, casing matters. Planet. Let's just say they're from Jupiter. Okay. So now we have created our person and alien, and now we'll try to use that function. So we are going to say alex.stats. Okay. That doesn't seem to like that either, though. See, it gives me a reason why. Okay. Well, first I'm supposed to try the say my name function. I think I might have to take an extra step there for a second. Say my name. Sim. Dot say my name. And both of them at least have access to the say my name function because we defined those methods. And valid receiver type sentient. What is that? Oh, is that complaining about the interface on line 31? Okay. Valid receiver type sentient is an interface type. Yep. Oh wait, yes, right. Okay. Okay, so the receiver can't be an interface. It's the parameter that becomes the interface. So what I can do now is I can pass multiple things as an argument here. So I can pass in S, which is a sentient being. So is anything that that interface would work on, which should be alien and person. Good. So then what I should be able to do is do stats Alex stats Zim, and I can pass them both in. So even though I type this as sentient, and Alex is a person and Zim is an alien, I'm able to use both because they both implement the sentient interface. Okay, so this way I can actually, so it's not that I can give different, both the same method without implementing the method separately like I did here, but what I can do is I can do functions on similar structures by using an interface. And there we go. So we see I was able to print out Alex's info and Zim's info without having to create two separate functions, one that takes in an alien and one that takes in a person, because I was able to clump them both as a sentient being since they both have a shared function, say my name. Okay, so that's... Now what if I wanted to pass in anything? What if I just wanted to create a function that you could literally pass in anything? Then you could just pass in an empty interface. So it would just be like, I could just do this. It would be S would be interface, and it would just be an empty interface, and that means I could literally pass anything in there. Okay, but then I gotta be more careful, but it should still work. And see, it still works because everything implements an empty interface. Everything at least has no functions. So that's sort of the deal there. So we've learned about interfaces, we've learned about maps, we've learned about structs and adding methods. So this has been a pretty jam-packed session. I'll see you guys later on.